a circle. All right. So for a line to be tangent to a circle, it has to hit a circle at exactly one point. Where it hits a circle at exactly one point, ooh, that's really bad. Mr. Bierspot, go much slower. There. Where it hits the circle at one point, it's going to make a right angle. Okay? The tangent line, this is a point of tangency. It's going to make a right angle with the radius of the circle at the point of tangency. So, what this question is asking is KJ tangent to the circle? To be tangent to the circle, it has to make a right angle there. If it's going to make a right angle, it has to form a right triangle. So, one side is 6, one side is 9, the other side is 10. Is 10 squared equal to 6 squared plus 9 squared? Is 100 equal to 36 plus 81? And the answer is no. No, it is not. So, this is not, KJ is not tangent to JP, tangent to the circle, because it doesn't form a right angle. Now, segment BC, they say that this is a tangent. They say this is 21, this is 13. What is the radius? Well, we do the Pythagorean theorem. What's the hypotenuse here? How long is this hypotenuse? X plus 13. So x plus 13 squared is equal to the other side squared plus the other leg squared. X plus 13 squared, to square this out, you take x plus 13 times x plus 13. Well, x times x is x squared. Outers is 13x. Inners is 13x. What's 13x plus 13x? 26x plus, and then last times last is 169. Now, what do you see on both sides that we have? X squared. So if we subtract x squared from each side, what happens? They cancel. So you get 26x plus 169 equals 441. Subtract 169 from each side. So 26x equals, subtract, we get a 2, through 7, and 272, and divide by 26. Somebody, calculator, 272 divided by 26. 10.1? 10.5? So the radius is 10.5 units long. Okay. All right. So if two segments are both tangent to the circle, then they're both going to be the same length. Okay? If two segments are both tangent to a circle, then they're going to be the same length as each other if they come from the same point. So, here's a really good problem about satellite communications. This satellite up here, it gets a signal from this tower here that beams up to the satellite and beams back down here and goes to here. So somebody in Mexico is making a satellite call to somebody in Africa. How long does it take their voice to get from this radio tower to the satellite, back down to the radio tower, and then along to the cell phone? So getting it from the radio tower to the cell phone will take a little bit more time too. But how far does this take it for this? Well, now let's figure this out. What we have here is we can draw a triangle here, where this is a right angle, so the hypotenuse is right here. The hypotenuse of our triangle is 35,786 kilometers plus the radius of the Earth, which is 6,371 kilometers. Somebody add those two up, please. What's 35,786 plus 6,371? 42,157. Now, the radius of the Earth is the same no matter where you're at. So this side of the triangle is 6,371. We need to find this side of the triangle. It's one of the legs. So we do the Pythagorean theorem again. We do 42,157 squared equals x squared plus 6,371 squared. Now we're going to get some huge numbers here, but I need some calculator help because I am not doing this on my own. 42,157 squared should be huge. Did it make it times 10 to the or not? No, just give me all the numbers. It's fine. Equals x squared plus, take 6,371 and square that out. Now we're going to subtract 40589641. Oops. 41 from each side. And we get 173,662. And then we take the square root of that. $4,167.2.8. Okay, so that's just one side. And then the other side, we just multiply it by 2. And that's how far the signal goes. So then it is 8.3345.6. Now, radio waves go at 300,000 kilometers per second. Okay? So if it goes at 300 kilometers per second, and this is the number of kilometers it is, if we divide it by 300,000 kilometers per second, we find the number of seconds it takes, which is 0 point something. Take 83,345.6 divided by 300,000. To the nearest hundredth. 0.28 seconds. So it takes about a quarter of a second to go from this ground up to the satellite and back to the ground again. Okay? So it's doesn't take very long. All right. Here's a little easier problem. Let's make this x, this y, this z, and this w. If AX is 7, how long's AY? 7. They come from the same point. If BZ is 2, how long's BY? 2. If CZ is 3, CW is? And DW is? So this side is 9. This side is 13. This side is 9. And this side is 5. So if we add all these up, the perimeter of that object is 36. Very good. Okay, let's find the perimeter of this object. A little bit more difficult now. Okay. A circular mirror with a radius of 12, so this is 12. Nope, this is not 12. This distance from here to here is 12. Okay, that is 12. This is 13. So we got to figure out how long BX is. Well, if this is 12 and this is 13 and this is X, 13 squared equals 12 squared plus X squared, or 169 equals 144 plus X squared. If we subtract 144 from each side, X squared equals 25. So X equals 5. So this is 5. So if BX is 5, then BW would be 5. And if this is also 13, then AW is 5 and AZ is 5. They're all 5. Now let's figure out the other one. We know this is 21. So if we have a right triangle with 12 and X and 21, 21 squared equals 12 squared plus X squared. What's 21 squared? Like 441, right? So if we subtract 144, X squared equals 97, right? Oh, wait, no. This is 144. 297. Take the square root of 297. 17.2, basically. Or 17.3. 17.2. So this is 17.2. This is 17.2. This is 17.2. So take 17.2 times 4 and 5 times 4, because there's 4 5s there, 4 17.2s. This is 8, carry the 8, 68.8, right? This is 20, so it's 88.8 is the perimeter of the frame. Okay? All dealing with Pythagorean theorem, Pythagorean theorem, Pythagorean theorem today. Okay? Lots of Pythagorean theorem. All right, so your assignment is out there already. I just put it out there after lunch. So your assignment's out there. Get to work, please.